When designing a strength and conditioning program, the first principle to consider is timing. This also applies to any training program where goals include concurrent muscle strength and power development, along with cardiovascular endurance training. Critical timing considerations include: how much time should the athlete allow between a cardiovascular endurance training session, that is, sprint intervals, and a strength training session? What is the optimal time of day for training? How much time does the athlete need to rest for optimal recovery? Common and usually necessary in athletic training environments is concurrent training. This involves multiple training modes, that is, strength training and cardiovascular endurance training in the same session. If not in the same session, these programs would occur closely together in the same 24-hour period. This often translates to 2 training sessions per day. Timing these training sessions, therefore, is critical. Muscle performance adaptations like strength and endurance are competing molecular events. During concurrent training, muscles get confused at the molecular level, leading to performance decrements. Decrements tend to work in favor of muscle endurance and against muscle strength and power gains. Mechanisms for competing molecular events are unclear. However, researchers have long suspected the mode of cardiovascular training, like running versus cycling. Historically, this has garnered the most attention. Current research focuses on the intensity of cardiovascular exercise along with duration of cardiovascular exercise. Original data on concurrent programming for muscle strength maintenance and development suggested that cycling was the preferred mode of cardiovascular endurance training. Although data favored cycling early on, a recent meta-analysis of 15 studies showed that muscle interference and strength decrements were greater for cycling versus running. Contemporary data suggests that the intensity of cardiovascular training is a more important determinant of strength decrements caused by cardiovascular endurance training than mode alone. In highly trained hockey players, concurrent training did not adversely affect muscle strength in the short term by high-intensity cardiovascular training like sprint intervals. Duration of cardiovascular exercise is also a significant factor contributing to muscle interference and strength loss during concurrent training. The longer the duration of cardiovascular endurance training, the greater the negative impact on muscle strength. Data does suggest that athletes should perform strength exercises before cardiovascular exercise to minimize interference if they are performed in the same session. Additional data suggests that the length of rest and recovery periods are also important training and programming variables. These relate to muscle confusion during concurrent training that causes strength decrements. Molecular mechanisms associated with muscle confusion need 6 hours and up to 24 hours to fully reset and avoid interference caused by CTE. The negative effects of concurrent training on explosive strength were greater when concurrent training was performed within the same session than when sessions were separated by at least 3 hours. Experts also recommended rest 2 days per week on non-consecutive days versus weeks on and weekends off to stay on a 24-hour cycle. Some best practices for programming include: trained athlete versus untrained person or moderately trained person is a primary consideration. Cycling seems to have less of an impact on muscle strength and power than jogging or running. High-intensity sprint intervals appear to have the least impact. Limit cardiovascular exercise duration to 20 minutes or less. Schedule rest periods of at least 3 hours between resistance training and cardiovascular training sessions. 6 hours to 24 hours is ideal. Schedule cardiovascular training every other day if muscle strength power is primary performance goal. If 2 modes of exercise are done within the same session, do before cardiovascular.